Hello everyone. So this is not one of my normal videos when I show different molecular dynamics simulations. So in today's video, I will be showing how you can extract data from the JPG or a PNG file of a graph. So as you can see, it is a graph of a hemispherical spectral emissivity versus wavelength. So my goal is to extract the data, that is the data points from this graph, and my ultimate goal is to see the relation or also try to find the equations from this graph. So how you can do that? So for this, first you need to load this graph into this website. The name of this website is as you can see, automaris.io. That is so this is mainly the website name, that is the WebPlotDigitizer. So with the help of this WebPlotDigitizer, you can uh, use your PNG file or JPG file and you can extract the data from there. So here you can launch it, and after launching it you can load your image. So you can choose any file. For example, I am choosing this file. So next you need to calibrate your axis. So to calibrate your axis, you need to show which is your x1, where your x1 and where is your x2. Then you need to show where is your y1 and you need to show where your y2 is. So after you are done with showing your axis, you can calibrate them. But you need to remember that in my graph, the x-axis is a logarithmic scale. So you can also mention that, for example, I am setting my x-axis as logarithmic, and you can also plot the points that it is it is from 0.2 to 3, and in case of y it is from 0.1 to 0.5. And after you are done with it, you can calibrate it, and now you have your axis. Next, you can choose your data points. To choose your data points, you can just go to datasets. You can add a dataset. For example, I have three datasets of temperature 1600, 2200, and 2800. So you can just write 1600 here, add a single dataset, and in this way, these are your 1600. So you can go here and you can start choosing your data points. So in this way you can choose all the data points. So I've already done this, and you can see that these are all my 1600, my 2200, and my 2800 datasets. So after you are done with choosing your datasets, you can see, you can view your data here. And after viewing them, if you want to plot them, you can just go to graph and plotly, and it will automatically plot your data for you. But as you can see, it is a very rough data set and you cannot understand anything from it. The main reason is that, as you can see in the x-axis, it is the linear scale, but you want the logarithmic scale. So what you can do is you can go to style, you can go to axis, and you can choose that your x-axis is actually logarithmic, and then you can simply arrange it in a way that you can understand it. And in this way you can plot your data, or you can visualize your data the way you want. So this is the portion where you are visualizing your data. But what happens if you want to find the equation that was used here, or if you want to use your own equation for fitting? So as you can see, there is an analyze portion here, and in analyze, if you go to curve fitting, you can see that you can fit your curve. So how do you want to fit your curve? Is it a linear fit? Is it a polynomial fit? Is it an exponential fit? You have an option. So here you can see that this trace 0 is my trace, and you can choose what kind of fit you want to use. For example, if I want to use the fourth order fit, I can just uh, say that it is 0.5. I can put random values here so that it will iterate and show me. So you see, after iteration it will show some kind of plot, but it is not actually too much accurate. To get more accuracy, you might need to increase the order, you might need to manually choose some of these parameters, and you can see there's a log sign here. So by logging the data points, you can choose to log some of the parameters and work with the other parameters. In this way you can get a nice fit. For example, as you can see, this is what I have done. So I have plot my data and I have fit my data in a way that it is more accurate, and I can now work with my parameters. Moreover, you can also do some other things. For example, you can choose your axis, you can rename your axis, you can rename your plot, you can do your legends, you can change the colors, you can change the design, you can also manually plot, you can also manually edit the points you have here, and then you can again trace them. So that sometimes you need to do that. When are those cases that you might need to do that? For example, as you can see in my graph, I don't have any data points beyond 2.6 or before 0.25 approximately. So what I can do is, I know that it has a linear relationship from here to here. So what I am doing is I am just saying, okay, what you can do, you start from 0 0, you go to this point and bring me a linear relationship. So that is what it is doing. It will, I gave these two data points and it is essentially giving me a fit including the equation. So it is very helpful in this way. You can also do an exponential fit, because for example, after 2.6 I have an exponential fit where my emissivity slowly turns to zero. It goes like this. So what I did is I chose some data points manually, and after choosing the data points manually I can just fit it using an exponential fit, and now you can see that I also have the equation for my exponential fit. So in this way you can, so to summarize, if you upload the png or the jpg file of a graph, you can extract the data points. From those data points you can do a fit, and using the fit you can draw out the equation which is the best fit for your case. Moreover, you can also extend your graphs beyond the data points that is present in the picture you have provided, and you can also do it for other cases. So I think it is a very helpful tool in analyzing and also drawing graphs. So I hope this video helps you. Thank you very much.